All right, welcome to the distance learning packet for IM2. Here we have week three's packet. This is page 3. Okay, so before we do this, let's go over some notes on what a function is. So a function. In words, this is what it means. A function is a relation, which like pairs things, is which each element of the domain is paired with exactly one element in the range. If you don't like the way this word is, that if you want to take out the word domain and you want to write the word right here, x, by all means you can. Okay, is paired with exactly one element in the range. Okay, again, exactly one, take out this, y. Okay, that's as simple as it is. All right, for every single x, there has to be exactly one y. Very simple. This is a way we can map x's. So notice how this would be a function. This is a function right here. This is a function because -3 goes to 5, 0 goes to 3, 2 goes to 2, 4 goes to -1 perfectly. But let's say it's like -3 and it goes, and there's another arrow to this. Okay, this becomes not a function because -3 goes to 5 and -3 goes to the y of 3 as well. This wouldn't work. Okay, that's what not a function looks like. Here, when it's a graph, we apply something called vertical line test. You should see it down right here. Okay, the vertical line test is when you draw a line straight down. All right, so let me draw this line straight down, and if it passes through one point, notice this passes through 1 point. Okay, this is 1 point. So this is a function. All right. But if it passes through multiple points, let me show you how that one would look like. How about we have something like this? And the graph looks something like this. And if we draw the vertical line down straight, and I would like you to notice that it that will actually intersect. Here is your 1 point. Here is your second point. Okay, the fact that it's 2 points, this is not a function. All right, so that's how you can tell. All right, so that is how you could tell which one is what's a function and what's not a function. Okay, all right, so let's take a look at number 1. Okay, so this one, these are just a list of points. Okay, so what we can do is we could put our x values here and our y values here. All right, so our x looks like it's 4. Okay, 4 and 3. So 3, 3, 4, 2, 2, 1. Oh man, okay, let me make more room. So it had 2, 1, 0. So 0, 1, 2, 3, 4, and there's a 2 here. Perfectly fine. Okay, and what about our y values? So let's look at our y values. -1, -6, -1, 2, 4, and 5. You just write it in order. The smallest is what? -6, -1, 2, 4, and 5. All right, okay, now just draw the arrows. Okay, so the first one, right, this, I'm going to represent by this arrow. 4 goes to -1. Okay, I'm going to, this point, 3 goes to -6. So 3 to -6. Purple, 2 goes to -1. So 2 goes to -1. Perfectly fine. Okay. Then we have, let's say, 1 and 2. So 1 and 2. Light blue, 0, 4. So 0, 4. And 2, 5. see, 2, 5. I can make gray. 2, 5. Uh-oh. Here's the problem. That 2. They said here that 2 went to make -1 and 2 went to make 5. This breaks. Okay, this doesn't work. So this is not a function. All right? Because of that -2. Okay? The arrows go to 2 different y values. So that's why it wouldn't work. All right, so let's take a look here. Number 2. The number of calories you burn since midnight at any time of the day. Well, the numbers of calories, right? So calories can be like 120 calories you can burn, like let's say you burn 120 calories walking to first period. Okay, then you burn 200 calories running to second period, so I don't have to yell at you. All right, then you burn 100 calories, let's see, walking to third period. Notice how these two numbers here are the same. Can you have the same amount of calories? Yes. Okay, there's no reason why you can't. So you would say, yes, this is a function. Right? Good? Okay. 3, this is a graph. So what we're going to do is apply the vertical line test. So I'm just going to draw the line and see how many points it crosses. Here's the vertical line. And that only crosses what? 1 point. Okay. Let's draw a second line. And remember, these are all vertical lines because we're looking at a function of x. Let's see. This is, the second point. No, this is only 1 point. This is still 1 point. Okay. So you would say, yes, a function. And here you would say passes the vertical line test. Okay. And let's do 4. Easy way of doing this is that you can just look at your x values. So notice here that the x values, right? The x value of 2 happened twice, all right? So we can take a look at this, and let's just write our x's here. Was -12, -8, -6, and -4. Did any of these repeat? No. Okay, so this is a function. All right. Now, if you're tripping out, let me graph this for you. Okay. So these are all negatives. So, all right. So -12 for probably what here? -12, 25. So this is -12, 25. Note -8, 25. So this is -8, 25. This is -6, 25. And the last one is -4, 25. Okay. So notice this can still pass the vertical line test because notice I draw the line straight down, right? That's a bad one. Okay. Same thing here. Trying to get the line as best as I can. All right. Okay. Yes, it's a function. If you graph it, it passes the vertical line test. Here, it passes the vertical line test. Okay. Notice the x doesn't repeat. Okay. Yes, the y can repeat. Good. All right. So let's take a look at 5 and 6. Okay. 5 again. Here you're going to. Let me just write it for you because you should be able to do this yourself. You're going to use the vertical line test. Okay. All right. And you can look at number 3 for help. Use number 3 for help. Okay. Or 4. because I graphed it on 4 as well. Okay, so same thing for 6. You're just going to use a vertical line test there as well. Is that it? Yep. So here are the notes if you still need it. All right. Now let's look at the set part. You're going to be comparing linear, quadratics, and exponential functions. They're all different. Okay. Let me just give you some core concepts to work with. All right. Here's the first one. You are never going to see the y value twice. For a linear. Quadratic, you will see the same y more than once. Exponent, the y changes more quickly than x. You would never see the y value twice. Linear, difference is the same for the value of y. The second difference is the same value for y. There's a common ratio for that. This is just algebraically, if you understand. Here is what I actually would use. It's just graphically. Linear looks like a straight line. Quadratics is a parabola. It looks like a smiley face or a sad face. A U or a N. Exponential will rise or fall quickly in one direction. Okay. It looks like an L. Right. Okay. All right. So now actually let's work through the problems now using these notes. Okay. All right, so the graph on the right shows the time and distance of 2 cars traveling along the same freeway. Which car has cruise control on, and how do you know? Okay, this is a horrible question because maybe some of you don't know what cruise control is. Cruise control is when your car goes at a steady rate. Okay, so you can set your cruise control to like 65 miles per hour on the freeway. On the highway, and your car will maintain that speed without you pressing on the pedals. Okay, so this cruise control. This is, let's say, going to be here cruise control. This is going to be a constant speed, also velocity, right? Constant speed, and something that is a constant speed, you would say it is linear. Okay, all right, because it has the same. Well, it has a constant rate, okay, of change, if you would like. All right. Which car is accelerating? Okay, so accelerating is when the speed changes quick. All right. So accelerating is like going from 0 miles per hour goes to like 60 miles per hour in, like, say, a Lamborghini, which would be like 4 seconds. Okay, so here something that goes quickly, we would say that behaves like a exponential. All right. Okay, curve something like this. All right, curve something like this. All right. So identify in figure 1 where car A seems to be faster. So this is the speed of the car here, right? So where in car A seems to be faster. So here, do you see here? A is bigger than B. B is down here. Here, A, B. Here, A, B. Okay, but here you see how it continues. This is B and this is A. So this seems to be the interval. They don't even give us numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like the first 12 boxes. All right, so it's like the first 12 units. Okay, here there should be some numbers here, but it's the first 12 units. Car A is faster than B. Okay, why? Because you see how A is has a greater y value than B here. For in figure 1, does car B seems to be going faster than A? For what interval? Well, after this, I think I'm gonna make this 12. So after 12 units, do you see how it flips? B goes on top. After 12 units, car B is faster than car A. Okay. and you could tell by that graph there. All right. What in the graph indicates the speed of the car? Time versus distance. So hold on. This might be done wrong. Hold on. Let me say. The graph shows the time versus distance. What? What is this car doing? Okay, hold on. This is a what? Time versus distance graph? So the slope. You're only looking at the slope then. Compare the rates of linear, quadratic shows the graph. The graph at the right shows the time versus distance. Hold on. Okay, so there were a couple of some mistakes that I've made. This question's weird. All right, so this is really here position then. This is a really bad question. Okay, so which one? So here you're looking at a constant rate, constant speed. So here this would be car A. Why? Because car A is a linear slope. Okay. Which car is accelerating? How do you know? Again, like what I said, it's exponential. All right, which is its positioning should change really quick. But whoever wrote this is not a physics person. Let me just say that. This is car B. Because it has a exponential slope. Okay. Identify the car in figure 1 which seems to go faster. In figure 1, which one goes faster? You can't really tell which one goes faster if you don't look at the slope. This one is so stupid. So this is what I would write, okay? This doesn't make sense, right? So the faster car has the greatest slope, okay? On the positioning versus time graph. All right. Because the slope here, the slope represents the speed of the car. Because I'm a physics person, the slope represents the speed / velocity. Of the car. Okay. So that's what I'm gonna write. I'm not gonna give you an answer, but this is weird. Okay. This is positioning. So here is actually which car's ahead. So A is faster. A is ahead than B. A is ahead than B. A is ahead than B. Then this is when B is ahead of A. Okay. What in the graph indicates the speed of the car? We actually said it right here. The slope represents the speed of the car. Okay. So you're looking at the slopes. If their cars now is shown, all 4 cars have the same destination. If the destination is 12 distance of 12 units from the origin, which car will you predict to arrive first? If the destination is a distance of 12 units, where is 12 units though? 1, 2, 3, 4, 5, 6. It's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is right here. So this is your 12 units, all right? And what is ahead in this car? In that look like? Let's see what is actually ahead. Well, it looks like what's on top? Well, it looks like B is first. Then here it's what? A. Then here it is C. So that is the order because that's the value of. It's basically the y value at the y. The y for B is bigger than A at 12 units. Okay. Which car would you predict to arrive? Well, this is what I would write. Okay. At 12 units. So at 12 units. Okay. The car B arrives first because it is ahead of car A, right? Then car C is last. Okay. How do I know that? I'm looking at the Y values. All right. Good. And is that it? Yeah, that's it. So again, I just wanted to clarify some answers with you. Okay. 9, you can't really determine that. It's a weird question. Okay. But yeah, everything else looks good. Okay.